Okay, good afternoon, all of you. Am I audible?
Yes, ma'am.
Screen is visible to you?
No, ma'am.
Now check.
Yes.
So from unit number 2, 1 point is remaining, and the point is stress trajectories. So all of you, please write down next point, stress trajectories, and draw these figures. Then I will explain. Okay. So please draw fast and let me know after your drawing is over. Okay, so your drawing is over. Yes. If your drawing is over, shall I explain?
Yes, ma'am.
Okay. So first we will see what is meant by stress trajectory. So you observe here there are two figures. First one is for cantilever beam and second one is for simply supported beam. Okay. So here you observe there are two lines are marked. This is continuous line and this is dotted lines. Okay. So a line is in a stressed body. Okay. So these are the lines in a stressed body tangent to the direction of one of the principal stresses at every point. So these are the lines are tangent to principal axis. Okay. So now you observe here in this figure, bending stresses are comes from normal stresses. Okay. Already you know that bending stresses which are coming from normal stresses and shear stresses are due to shear force. Already you know that sigma b which is due to normal stress and shear stress that is tau which is equal to shear force. So whenever bending stress will be generated, so these bending stresses will come from normal stress and shear stresses comes from shear force. Okay. And Already we have discussed, suppose this is a cross section of beam and this is a stress distribution diagram. Okay, this is a stress distribution diagram. This diagram is for bending stress and this diagram is for shear stress. Okay, so you observe here in bending stress, the maximum stress, okay, the maximum stress is at extreme fiber. Maximum stress is at extreme fiber and 0 at neutral axis. Whereas in shear stress distribution diagram, the maximum stress at neutral axis, maximum stress at neutral axis and 0 at extreme fiber. The screen is visible to you?
Yes, ma'am.
Yes.
Yes, due to network issue, meeting is rejoined. So this is cantilever beam.
But madam आवाज येत नाही मॅडम तुमचा जास्त.
No, may I
आवाज
audible?
कमी आहे मॅडम.
Yes, may I audible?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes.
Yes, this is cantilever beam and this is simply supported beam. Okay, simply supported beam. Simply supported beam. So already all of you know that. So bending stresses will comes from normal stress, sigma, and shear stresses will come from shear force. Okay, so we have learned that is stress distribution diagram. Okay, stress distribution diagram. This is the stress distribution diagram for bending stress and this is the stress distribution diagram for shear stress. Okay, so you observe here in stress distribution diagram, bending stress is maximum at extreme fiber, maximum at extreme fiber and 0 at neutral axis, 0 at neutral axis. Whereas in shear stress distribution diagram, shear stress is maximum at neutral axis. Shear stress is maximum at neutral axis and 0 at extreme fiber. 0 at extreme fiber. Okay, already we have discussed these parts. So now we will see what is meant by exactly stress trajectories. So by investigating stresses at many cross sections. Okay, so after investigation, conclusion is stresses at many cross sections. Okay, stresses at many cross sections of beams can determine how principal stresses vary throughout the beams. Okay, so you observe here. So these lines are drawn. Okay, these lines are drawn, and this line shows the how principal stresses are vary point to point. Vary point to point. And these curves are orthogonal. So this is called as stress trajectory. So stress trajectory means we have to draw lines orthogonal curves, and these curves are represent the principal stresses at various points. So this is called as stress trajectories. So from this figure, the solid line indicates compressive principal solid line indicates tensile stresses, and this dotted line indicates compressive stresses. Okay, once again I repeat, you observe here in both figures there are two lines. So this solid line indicates tensile principal stresses, and this dotted line indicates compressive principal stresses, and both the lines are intersects at 90 degree at every trajectories. Okay, 90 degree. Okay, these the stresses intersect at 90 degree and every trajectory crosses the longitudinal axis. So this is our longitudinal axis, and this trajectory makes 45 degree angle with longitudinal axis. So you observe here, this solid line and this dotted line creates 90 degree angle between them, and this stress trajectory line creates 45-degree angle with respect to longitudinal axis. Okay, so once again repeat this sentence. So these solid lines indicates tensile principal stresses and this dotted line indicates compressive principal stresses. Okay, so this tensile principal stresses curve and compressive principal stresses curve intersects each other at 90 degree. Intersects each other at 90 degree. You observe here. Okay, and these curves are creates 45-degree angle with respect to this longitudinal axis. म्हणजे ते काय करतात की एकमेकांभोवती 90 डिग्रीचा अँगल करतात आणि लॉन्जिट्युडिनल ऍक्सिस सोबत किती डिग्री अँगल होतोय 45 डिग्री. ओके, सो ऍट द टॉप अँड बॉटम सरफेस ऑफ द बीम where shear stresses are zero. Okay, so you observe here shear stresses are zero where at the top surface. So shear stresses are zero at extreme fibers. Okay, so at that point trajectories are horizontal or vertical. So wherever shear stresses are zero, at that point stress trajectories are horizontal or vertical. Stress trajectories are horizontal and vertical. So these stress trajectories gives the principal stresses. Okay, stress trajectory gives the principal stresses but no information about magnitude of stresses. Okay, so these stress trajectories gives direction of principal stresses. म्हणजे या कर्व मुळे आपल्याला काय मिळतं तर डायरेक्शन ऑफ प्रिन्सिपल स्ट्रेसेस, बट दिस ट्रॅजेक्टरीज डज नॉट गिव्ह द मॅग्निट्यूड ऑफ principal stresses. So once again I will repeat from starting. So these are the line after stressing of beams. So bending stresses in the beam will comes from normal stresses and shear stresses comes from shear forces. Okay, so after investigation stresses at many cross sections, that means suppose we have taken here cross section, here cross section, here cross section. So stresses at many cross section we can determine how principal stresses vary. So after taking section we will understand how principal stresses vary throughout the beam. Okay, then we can construct two orthogonal curves. So this is called as stress trajectory. Okay, this is called as stress trajectory. Now we will move towards these two lines. So this solid line indicates tensile principal stress and this dotted line indicates compressive principal stress, and these tensile and compressive principal stresses curves are exactly perpendicular to the each other. That means it creates 90-degree angle between them, and these trajectories are creates 45-degree angle with respect to longitudinal axis. With respect to longitudinal axis. Okay, so at the top and bottom of portion. So in the beam at the top and bottom of portion where shear stress is zero. So at that point stress trajectories are horizontal and vertical. That means if shear stress is zero, at that point trajectories are horizontal and vertical, and stress trajectories gives the direction of principal stresses. Stress trajectories gives only direction, does not give magnitude of principal stresses. So this is the theory related to stress trajectories. Now I will tell you, so please write down fast. Okay, so write down from first. A line in a stressed body, a line in a stressed body, a line in a stressed body tangent to the direction, tangent to the direction, tangent to the direction, tangent to the direction, tangent to the direction of one of the principal stresses, of one of the principal stresses at every point, at every point, at every point, at every point through which it passes, through which it passes, through which it passes, through which it passes. Then write down second point. Second point. Bending stresses contribute, bending stresses contribute, bending stresses contribute, bending stresses contribute to normal stresses. Bending stresses contribute to normal stresses. Normal stresses. And shear stresses are due to, 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 shear stresses are due to shear force, due to shear force, due to shear force. Full stop. While calculating the principal stresses in beam, while calculating the principal stresses in beam, calculating the principal stresses in beam, bending stresses are maximum, bending stresses are maximum at extreme fibers, maximum at extreme fibers, and zero at neutral axis, and zero at neutral axis, zero at neutral axis. Full stop. Whereas shear stress maximum at neutral axis, shear stresses are maximum at neutral axis, maximum at neutral axis, maximum at neutral axis, and zero at extreme fiber, zero at extreme fiber, zero at extreme fiber, zero at extreme fiber. Full stop. Continue next point, third point. By investigating stresses, by investigating stresses at many cross section, stresses at many cross section.
Madam, repeat.
Okay. By investigating stresses at many cross section of beam, stresses at many cross section of beams, many cross section of beams, we can determine how principal stresses vary, how principal stresses vary, how principal stresses vary throughout the beam, how principal stresses vary throughout the beam, throughout the beam, throughout the beam. Then we can construct two systems of orthogonal curves, two systems of orthogonal curves called stress trajectories, called stress trajectories, called stress trajectories, called stress trajectories. Full stop. Write down next 4 point. The solid lines are indicates, the solid lines are indicates, solid lines are indicates tensile principal stresses, tensile principal stresses, tensile principal stresses, tensile principal stresses, and 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 dotted lines are indicates, dotted lines are indicates, dotted lines are indicates compressive principal stresses, compressive principal stresses. Compressive principal stresses. Full stop. Full stop. The curves of the curves of the curves of tensile principle and tensile principle and compressive principal stresses, tensile principle and compressive principal stresses intersects at 90 degree, intersects at 90 degree, intersects at 90 degree to each other, 90 degree to each other, 90 degree to each other, and every trajectory crosses, every trajectory crosses, every trajectory crosses, every trajectory crosses the longitudinal axis at 45 degree, longitudinal axis at 45 degree, longitudinal axis at 45 degree, longitudinal axis at 45 degree. Full stop. Write down last point. At the top and bottom of beam, at the top and bottom surface 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 of beam, where shear stresses are zero, where shear stresses are zero, where shear stresses are zero, shear stresses are zero, shear stresses are zero. The trajectories either trajectories are either horizontal or vertical, horizontal or vertical, either horizontal or vertical, either horizontal or vertical, either horizontal or vertical, either horizontal or vertical. Full stop. Note that, note that, note that, note that, note that stress trajectory gives, stress trajectories gives, stress trajectories gives, stress trajectories gives the direction of principal stresses, the direction of principal stresses. Stress trajectories gives the direction of principal stresses. But no information about magnitude. No information about magnitude of the stresses. No information about magnitude of the stresses. No information about magnitude of the stresses. Full stop. So this is the theory related to stress trajectories. Now our unit number 2 is over. So I end the meeting. You please rejoin once again. Okay.